So we are now sa chapter 6, everyone. This is entitled Testing Hypothesis. Okay, so by the end of the session, I hope you should be able to formulate a null and alternative hypothesis and then state the procedure for hypothesis testing, differentiate between one-tailed and two-tailed tests, and also distinguish between type 1 and type 2 errors. So we will be learning how to make a hypothesis this morning, and after that we will be discussing the different types of hypothesis because we have lots of types of hypothesis, and then after that we will do hypothesis testing. So starting today onwards, we will all be talking about testing our hypothesis. So we will be moving on to the different statistical tools, especially inferential statistics. And we will be using JASP, and there will be times that we will do the computation manually. So be ready always with your calculator and also your software there in your gadgets, either your laptop or your desktop, since we cannot use JASP sa phone. Yeah. Natuluan ko na ni Cherry. Kanang iyahang live. Next time. Sige. Let's talk about hypothesis. When you say hypothesis, class, it's an educated guess. Like it's a tentative solution to our problem. But take note of the word educated. You just don't propose a solution to a certain problem, but you have to do research first. You have to have a lot of readings first before you can formulate your hypothesis. So again, this is a proposal, a proposition that will serve as an explanation to a certain occurrence or a certain phenomenon. And we are actually proposing a solution to a certain problem. Now, the unique characteristic of hypothesis is, since this one is just an educated guess, it needs to be tested first. So your hypothesis, when you make a research and you make your own hypothesis, you have to make sure that this hypothesis are capable of being tested. And we have available scientific methods that can be used in order for us to really test whether our hypothesis is correct or not. Okay? So what are the characteristics of hypothesis? It should be clear and precise, definitely, since we are proposing an explanation or a solution to a problem. Next, it should be capable of being tested. I have already stated this a while ago. Kasi a proposal will be meaningless if we cannot prove it, if it is true or not. And then it should be able to relate to a variable. So remember that in research, we have lots of variables, and most of the time we are using the independent and the dependent variables. We are identifying these two. Well, when you say independent variables, these are the variables that being manipulated and controlled in the study, while our dependent variable is also known as the outcome variable, since that will be the outcome that we will get if we manipulate the independent variables. So when we propose a certain hypothesis, a guess, an educated guess, or a proposal to our problem, then it should be able to relate to this identified variable. So kasi baka yung ginawa nating hypothesis wala namang kinalaman sa ating independent and dependent variables. And then the hypothesis should also be limited in scope and must be specific. So we have to be specific to what problem are we addressing, or to what phenomenon are we trying to explain. So we have to define the scope first of our proposition. Kasi baka magpo-propose tayo ng solution to a problem and it's very like vague or masyadong broad yung coverage na we cannot really get a specific result, or maybe we cannot finish our study or our research sa bonggang solusyon sa problema na being identified. Wait lang. Okay, another one. Hypothesis must also be stated in very simple terms. Class, when you do research, please do not use highfalutin words that will be confusing to our readers. So we have, class, to assume that our readers are not all like healthcare professionals or related to our field. So we have also readers, mga layman readers natin, and we have to take that into consideration that if we are going to use words, yung mga medical words natin, hindi yun nila maintindihan. So be simple, use simple terms in making the hypothesis. And it must be consistent with most known facts. So that is the reason why it's called an educated guess, since before you can really formulate your own hypothesis, you have to do research first. Okay, you're doing your own paper, but you have to research. You have the RRL, we have the related literatures and studies, and this is where we get our educated guess. So again, it must be testable within a reasonable time. When we make hypothesis, you have to make sure that we have available scientific methods in order for us to really test this propositions, but you have to consider also that we are time bounded. Okay, we are time bounded, and when you say meron tayong limited time, just like when you are going to do your research next year, you will just be given a year to complete everything. One sem for the formulation of your paper from the introduction to the methodology, and another sem for the conduct of the study, for the data gathering procedure. So you have to make sure that when you make your hypothesis, it will be testable in that time na binigay sa inyo. And must explain the facts which most need explaining. So that is all for the characteristics of our hypothesis. Now let's move on to the categories of hypothesis. This is very important for you to know, since ito talaga yung ina-identify for research. Sa research paper mismo, what we are writing there is itong first classification based on their formulation. So it's either null hypothesis and alternative hypothesis. Okay, yan yung ginagamit sa paper. But during the statistical test, we also use the directional and the non-directional hypothesis. This will help us identify the correct statistical tool that we are going to use to analyze and interpret the collected data. Okay, so let's start with the first one, the null hypothesis, kasi ito yung pinaka-common and ito yung hinahanap talaga ng mga panelists. Minsan kasi the students are using alternative hypothesis, and the panel would most likely ask you to revise it and make it as null. Kasi in statistics, we actually always test the null hypothesis, and our decision will always be either to accept or reject our null hypothesis. Now, what is a null hypothesis? The null hypothesis is a hypothesis. It's an educated guess, but it's stated in the or on the negative side. So negative yung pagka formulate sa kanya, And we are actually denying relationship or anong tawag dyan, difference here between our variables. So ang sa null hypothesis, if you are proposing a new drug, you will be stating it in the negative side, and you will be denying, or you will be stating that the drug that you are proposing is not really effective. Yun yung tinatawag na null hypothesis. So for examples, we have here giving feedback does not improve learning. That's a null hypothesis. If you read the statement, it's like having a guess, right? Guess na, oh, giving feedback does not really improve learning. So, ayun. Pero pag ginawa yan, meron yang like RRL kasi dapat educated, yes. But nevertheless, look at the does not, meaning we are denying the existence of the relationship or the effect or influence of something. Okay? So again, giving feedback does not improve learning. Another example of null hypothesis is that two groups do not differ in their response to the method of teaching. So like this one is an experimental study involving the use of the different methods of teaching, like doing lecture or doing experimental doing experiments in the laboratory. Ano yan siya? Experiential learning. So like when you are going to test kung ano ba yung suitable or most appropriate to the students. So ayun, meron dalawang grupo. So you will be having an educated guess there kung ano ba yung effective, kung ito bang pure lecture or experiential learning, for example. But since this one is a null hypothesis, so we will be denying the existence of the relationship or influence of the variables. This time we are denying the response of the groups that we have in the experiment for the two methods of teaching. So again, the two groups do not differ in their response to the method of teaching. And then another one, this is most applicable sa pharma. There is no significant difference between the blood pressure lowering activity of drug A and drug B. So suppose you want to conduct a research of like a drug for hypertension, and example drug A is your new drug. It can be coming from a plant material, and drug B will be an existing antihypertensive already in the market, so it's already proven. Now, you are proposing that new drug, right? The drug A for the hypertension, but if you are asked to make null hypothesis, it should be in the negative form. So like when you say there is no significant difference between the activity and drug A and drug B, we are denying the fact. Okay? That's null hypothesis. Kasi pag tiningnan natin yung isa, dalawa ito sila, under sa based on how the hypothesis is being formulated. Alternative hypothesis naman is on the affirmative side. So this one is just stating the hypothesis in its positive form, and that we are affirming or confirming the existence of the difference or relationship between our variables. Actually, the examples there are the same with that of the alternative hypothesis, except that this one is, kung nakikita nyo, does not, do not, no, negative side siya lahat. Etong alternative hypothesis is, yes, we are like guessing that the variables have relationship or they have effect to another variable. So we have giving feedback improves learning. And then experimental methods are more effective than lectures. And then there is a significant difference between the blood pressure lowering activity of drug A and drug B. So that is how we formulate our alternative and null hypothesis. Let me just open a sample research for you to really see how this is done sa mga pharma research natin. Though I believe you already have this sa inyong high school days. Ay, ayan. Wait lang, I have lots of email, man good. Kalimot na sa password. Okay, kung read messages. Okay, so just like this one, let me see. This one is from the 3rd year. Oh, this is not, this is the REC pala. This one. Revised paper. Okay, this is an ongoing research ngayon. Magkakandak pa lang sila ng experiment sa school. The title of their study is Antibacterial Activity of Formulated Soap from Citrus aurantifolia or the key lime and Psidium guava leaves ethanolic extract against Escherichia coli or E. coli. So if you look at the title, they have two plant materials here. The key lime and the guava, they are formulating a soap against Escherichia coli. So let us look at their hypothesis. Wait lang ha, kasi medyo mahaba na daw ang format. Okay, they have their statement of the problem. These are the questions that you need to answer in your study, but they have here the null hypothesis. Okay, so ito yung sinasabi ko kanina, in research most of the time we are looking for the null. Okay, we are requiring the null hypothesis. Actually, tatlo yung null hypothesis nila. Number 1, there is no significant difference between the mean zones of inhibition of Citrus aurantifolia leaves ethanolic extract, the Psidium guava leaves ethanolic extract, ceftriaxone, and the distilled water against Escherichia coli. So we are denying the existence of the relationship between the variables or the difference. Kasi ano man ito, antibacterial na study. So pag antibacterial na study, we are measuring here zones of inhibition. Lalagay kasi nila yung kanilang plant material sa disk. Like para siyang filter paper na ilalagay nila doon. Example yung Citrus aurantifolia. Tapos ipa-place nila in a petri dish with the bacteria. And then after that, magme-measure sila ng zone of inhibition. Pag sinabing zone of inhibition, yan yung area around the disc na nilagay nila containing their drug na nawala, namatay yung bacteria. So it will be really very visible pag namatay yung bacteria. And then dito, yung kanilang hypothesis is walang difference yung mga mean zones of inhibitions for the treatments. So marami kasi silang treatment, dalawang plant materials, and then they have the positive control, the ceftriaxone. The ceftriaxone is an antibacterial already available in the market, and they have the negative control. When you say negative control, we will expect na wala talaga yan siyang activity like water. Water cannot really cause or kill E. coli. So yan yung kanilang null hypothesis. And then number 2, there is no significant difference between the mean zone of inhibition of the formulated soap. Baka magtaka kayo ha, parehas lang man ma'am, Citrus aurantifolia, Sodium guava, ceftriaxone, and distilled water against E. coli. Hindi kasi siya magkapareha. The first one is using the extract. So this one, the extract coming from the two plants, but the second one is already the formulated soap. So marami kasi silang testing na gagawin. Mag-extract muna sila ng sa plant material nila. Tapos i-test nila yung extract kung effective ba. And then after that, maggagawa na sila ng sabon and then ite-test nila ulit. Okay? And then there is no significant difference between the mean zone of inhibition in the mean zone of inhibition, bakit the citrus aurantifolia leaves extract and the formulated soap from the plant against Escherichia coli. So, yung ikatatlo, baka ma-confuse kayo, i-test din nila ang difference. Kung meron bang difference yung extract, dalawang extract and yung sabon na ginamit nila. Kasi baka effective yung extract pero yung sabon hindi na. So, yan yung mga educated guess nila sa problem na ito. They are looking for an antibacterial agent against Escherichia coli. So hindi naman basta-basta na guava and then citrus aurantifolia, yun yung gagamitin natin. Meron yan silang, syempre, background study for that before they have formulated the null hypothesis, whether the two plants are effective or not. But nevertheless, these are all null hypotheses and they are stated in the negative form. My problem is I don't think I have an example here of an alternative hypothesis kasi nga na-mention ko sa inyo, sa research, we are always using the null and not the alternative. Let me just check whether I have it or not. This study does not have a hypothesis. They have. Okay, they have. But this one is still class? Null hypothesis. That's the title of the study again. Quality control testing of unnotified underarm whitening creams. This is also an ongoing study sa pharma. They will be looking into the unnotified underarm whitening creams, yung mga binibenta ngayon, di ba marami yan, mga cosmetics, like promising na maputi mong ilok. And they will be looking into the products na hindi registered sa Food and Drug Administration. So yun yung goal nila sa research. But they also have their null hypothesis. So they have it here, hypothesis, the unnotified underarm whitening creams dapat do not conform to the Food and Drug Administration quality control standards. So negative form pa rin ha kapag ka nagna-null hypothesis tayo, always yan siya naka-no or naka-not. And then yung alternative hypothesis is on the positive side. So even though they did not write null hypothesis here, they just write hypothesis automatic class. When you look at their hypothesis, you can identify that this one is a null hypothesis. Okay, I hope that is clear. Any question about the null and the alternative ones? Baka may gusto kayong i-clarify. Wala? Sure na? Kasi na. Okay. We have now the other types of hypothesis, the non-directional and the directional. So from the name itself, non-directional, we will just predict here that there will be a difference between the two groups that we are testing, but we will not really specify how these two differ. Okay? So pag na-identify nyo na the hypothesis is non-directional, then that's the time we can also decide that we are going to do two-tailed test for our hypothesis. Okay? So, ito naman, directional hypothesis. Meron tayong direction here. Like if the hypothesis is stating that there is no significant difference, automatic kasi non-directional yon. Pero pag may nakita kayo class sa hypothesis na nakalagay na greater, less, better, or worse, that is called a directional hypothesis. Merong direction, like we are giving favor to one group over the other. Okay? So makikita natin yan. The boys are greater than the girls in terms of something. Pag ganun yung hypothesis, directional yun. Or less or better, drug A is more effective than drug B. You have there the word more, like we are favoring drug A over drug B. That is directional hypothesis. And if you have identified that the hypothesis is directional, that's the time you have to decide also that we are going to do one-tailed test for statistics. So let's go back to our examples here. Giving feedback improves learning. You cannot see any directional words or terms here. So this one class is an alternative hypothesis, at the same time non-directional. Pero ito, experimental methods are more effective than lectures. So this type of alternative hypothesis class is favoring more the experimental methods than the lecture. So merong direction. So ito, ang tawag nito, directional hypothesis. Itong ikatlo, there is a significant difference between the blood pressure lowering activity of drug A and drug B. So in this case, wala naman tayong fini-favor between drug A and drug B, right? So ano siya? Non-directional hypothesis. Again, pag non-directional, we will be doing two-tailed test here. Okay? Two-tailed test. Pero pag directional, gaya ng itong number 2, we will only be using one-tailed test since we are again favoring one group over the other. So yun yung apat natin na types of hypothesis. I hope klaro yan siya. Pag null, it's ang pinaka way of identifying it is it is stated in the negative form. So always yan siya, may no or may not. And then pag alternative, positive form naman siya. Pag non-directional, wala tayong binibigyan na favor ng group. So we will just predict if there is a difference or a relationship between the two. So we will be using two-tailed test there. Pero pag directional hypothesis, may favor na binibigay sa one group over the other. So you will see comparison terms like greater, less, better, worse, or even more. So this time, we will be using again one-tailed test. Okay? Questions or clarifications about this? Baka may gusto kayong itanong. Okay? So I hope may kasinabutaan ng hypothesis na to, ha? Sige. Now, we also have class the so-called errors in hypothesis testing. Actually, we just have two types of errors, the type 2 and the type 1 and the type 2. The type 1 can also be called alpha and type 2 will also be called beta. Okay? Now, sa hypothesis testing, di ba, I told you a while ago that we are using the null hypothesis. Yung HO dyan class, that is our symbol for null hypothesis. Ang symbol ng alternative is HA. Itong HO, null hypothesis ito. Now, for example, after gathering the data, after doing the experiment, we have found here that the null hypothesis is true. tama siya, yung pag-deny natin ng existence ng relationship or difference, tama according sa results ng study. So the correct decision to make is to accept the null hypothesis. Makikita natin yan siya sa conclusion ng mga research papers. May nakalagay talaga doon whether they are rejecting or accepting the null hypothesis. So this time, since the null hypothesis is true, then the correct decision to make is to accept the null hypothesis. It will become an error if the null hypothesis is rejected, which in fact, tama naman siya. Na pagka ganito class, na supposedly tama si null hypothesis but it was rejected, ang tawag dyan type 1 error or alpha. Okay? Alpha error. Yan siya again, or type 1 error. Now, how about if we have found after the data gathering procedure or the experiment that the null hypothesis is false? Hindi pala siya tama. Like pag sinabi mong there is no significant difference between the activity of drug A and drug B. Tapos nakita natin sa experiment na magkapareha naman sila ng activity. So null hypothesis is false. Now, what's the best thing to do? You have to reject the null hypothesis because that is false. Hindi siya tama. So the correct decision again is to reject the null hypothesis. It will become an error in hypothesis testing if you have accepted the null hypothesis na false naman siya. So dalawang errors lang tayo for hypothesis testing. Type 1 and type 2. So you have to be clear with that. You have to make sure that for type 1 error, hindi mo ma-reject yung totoong null hypothesis. Sa type 2, kailangan mo siyang i-reject kasi hindi siya tama. Any question about our errors in hypothesis testing? Actually, this one is like sabutable. Madali naman siyang diba? I-understand. Alam mo, kalibog as dapit ng type 1 and type 2. So you have to really know that by heart. Now, we have the so-called level of significance sa mga research studies natin, and we call that alpha. Okay? Alpha yung tawag natin sa level of significance. And we set this at the beginning of research. The researcher mismo yung magsaset ng level of significance niya. Okay? So, sa alpha kasi, we are wishing to limit the probability of making type 1 error. So, hindi natin gusto na ma-reject yung totoong, yung correct na null hypothesis. So, we are, again, setting an alpha. So, typical values of an alpha are 0.05, that's 5%, 0.01 or 1%, and 0.001. Okay? Ano ibig sabihin nito? Itong mga values na ito are actually room for errors. Okay, room for errors ito. So pag sinabing 5%, 0.05, 5% yung binibigay natin na room for error since we are just doing sample testing, hindi naman siya whole population. And then the remaining 95% is our confidence level, meaning we are confident na 95% of our data is correct. Tama. Okay? So, again, ang alpha, siniset yan siya ng researcher. Most of the time, if it is a social study, or tawag dyan, yung mga quantitative descriptive studies like doing survey using our questionnaires, ang alpha na siniset nila dyan is 0.05. So we are like giving 5% room for errors. And then pag experimental na studies, 1%. We are using 0.01 for the level of significance. That's how strict we are in terms of experiment, especially if we are dealing with drugs. Kasi hindi pwedeng masyadong malaki ang room for error natin. Okay, we are talking about life. Okay, so let's see examples of research na natapos na ha, para makita natin kung ano yung ginamit nila na alpha. Hanap mo na ako, wait lang. Kaya puno ako ang email. Nasa email ko kasi ito lahat. I think they have the result here. But this one is a medtech na study. Anyway, you can relate to this study. Is medical fake news and fear-mongering during the COVID-19 pandemic, the impact on the vaccine confidence among the millennials. So they are looking into medical fake news and fear-mongering during the pandemic. Ito, actually pandemic paghihapon. But this was done last year, and yung impact ng mga medical fake news sa vaccine confidence ng mga millennials sa Jensen ito. Let me move into the results of their study. If ano yung alpha na ginamit nila. Wait, let's go back to their hypothesis. What was again their hypothesis? Null hypothesis. There is no significant relationship between medical fake news and fear-mongering and vaccine confidence among the millennials. Wala daw relationship even if nagkalat sa internet ngayon yung mga medical fake news and yung vaccine confidence ng mga millennials. Tingnan natin ang result ng kanilang study since this is already done. Medyo mahaba ito. Ay, nalampas na yun. Abot nag-discussion section. Ang haba ng discussion nila. Okay, result ng ginamit nila. Here, 0. Significance 0.773. Yeah, this one. 0.05. I cannot highlight it. I'll just annotate na lang. This one. So nakalagay dyan, the Pearson-R correlation was used to determine the significant relationship or correlation between medical fake news and fear-mongering during the COVID-19 pandemic to the vaccine confidence among the millennials. As shown in table 6, the R value shows a negative 0.016, which indicates a very weak negative to no correlative relationship between the variables with a significance level of 0.773, which is greater than the critical value of 0.05, meaning they are using 0.05 as their limit. Kaya lang nakalagay mas mataas kasi yung kanilang computed value, the p-value nila is 0.773, mas mataas siya sa significance value natin na 0.05. So kaya nagkaroon sila ng decision. Ito yung decision nila, which indicates that the null hypothesis should be accepted. So inaccept nila yung hypothesis nila na wala ngang relationship yung medical fake news and fear-mongering and yung confidence ng mga millennial sa vaccine. So I will teach you that hindi niyo pa siya masyadong mag-grasp ngayon kasi this will be used, lahat ng ito gagamitin natin when we do the testing na. Pag nag-start na tayong mag-t-test, mag-ANOVA, or mag-Pearson correlation. But nevertheless, itong mga values na ito na sinasabi ko sa itong level of significance, ito yung ginagamit sa research. So since that was a survey research, their value for the level of significance or their alpha is 0.05. Actually, yung mga experimental studies sa pharma, 0.05 din ang ginagamit Though sabi ko kanina na we are strict with the experimental studies, but those na gumagamit ng 0.01, yun na yung mga gumagawa na talaga ng drugs using like human subjects, the vaccines. Pag nag-test yan sila and then nag-statistics na, most likely 0.01 yung gamit nila dyan para sure talaga sila sa effect ng kanilang ginagawa na drug. So again, yung type 1 error or alpha error nangyayari ito if we are rejecting the null hypothesis na totoo naman talaga siya. Okay? Again, type 1 error, kailan mangyayari? Pag ni-reject mo yung null hypothesis when in fact it is true. Okay? And among the type of errors in statistics or in hypothesis testing, this type of error is considered more serious. And that is the reason why we really need to avoid this. Thus, we have the level of significance, which is also called the alpha. So, kailangan talaga nating i-avoid na ma-reject natin yung totoong null hypothesis. Kasi for example, there is no significant difference between the anti-hypertensive activity of drug A and drug B. Ang result ng experiment mo supposedly tama, wala nga silang difference in terms of effect. Kaya lang, nagkamali ka, ni-reject mo yun. So that one is a very serious one kasi wala na yung drug mo, hindi na siya hindi mo na siya magagamit. Kasi example, drug B is like, anti-hypertensive na existing in the market already. Tapos nakita na wala pala silang difference in terms of effect, which means you're proposing na drug is effective. So, ni-reject mo. Ngayon, may useless na yung ginawa mong drug kasi ni-reject mo yung null hypothesis. Nag-believe ka na merong significant difference yung effect nila. And then nilagay mo pa talaga na since drug B is already out in the market, it's effective. So drug A will not be effective anymore. So that's a serious one. So nasayang na ang lahat. So kaya we need to really avoid this type of error. Si type 2 or the beta error, kailan mangyayari? If we accept the null hypothesis when in fact it is false. Okay, so frequently, dahil ito sa small na sample size. Okay, pag ni-reject mo again, si null hypothesis na false naman siya, type B error yan siya. Pero it's still an error ha. So we really need to be sure when it comes to our hypothesis testing and the decisions that we are going to make. Okay? Now, for the testing sa statistics, na-mention ko ito doon sa part ng directional and non-directional hypothesis. We can make one-tailed test or we can do one-tailed test or two-tailed test. Okay? Pag one-tailed test, ito yung ginagamit natin if our hypothesis is directional. Okay? Pag direction ha, merong direction, you can see comparison terms or comparison words such as greater, lesser, more, worse, or whatever as long as there is comparison. Again, gagamit tayo ng one-tailed test. Since we are giving favor to one group over the other, then kasi yung probability ng distribution ng ating data will also be located in one tail. Remember our normal distribution, it's like a bell-shaped, right? Ganito yung normal distribution natin. Now, if we are favoring one group to another, most likely the results will be concentrating here, example dito na part. So kaya tinatawag yung testing na one-tailed test kasi supposedly hati yan sila and they have to be mirror image of the other. Kaya lang again, we are favoring one group. So most likely the distribution of the result will be located in one tail only. So if we are going to do analysis of the numerical data, we are going to use one-tailed test. Okay? So this is also known as directional test, and you can easily identify that through the comparison words in the null hypothesis. But if there is no comparison words, talagang ano lang nakalagay, there is a significant difference between drug A and drug B. Walang comparison. I mean, walang favoring of one group to another. Walang direction. So, non-directional hypothesis yon. And if we're going to analyze and interpret the numerical data, we will be using two-tailed test. Okay? Two-tailed test yung gagamitin. So, kasi since wala tayong fini-favor na group over the other, if this is the normal distribution class, our data, the distribution will really be located on both tails of the probability distribution, or itong yung ano natin, graph natin for our data. So again, ito yung gagamitan natin ng two-tailed test. So tandaan nyo yun ha, kasi later makikita nyo talaga i-apply natin yung mga types of hypothesis, null or alternative, and then the directional and the non-directional. Apply natin kung anong test yung gagamitin, one-tailed or two-tailed test. Okay? So wala kang makikita here na comparison terms. Example, boys and girls do not differ in mathematics ability. You are not favoring the boys, you are not also favoring the girls. It's just that they don't differ in terms of their mathematics ability. So since walang comparison terms, non-directional ito, non-directional test din yung gagawin. Two-tailed test. Okay? Questions so far before tayo mag-move on? Malapit na tayo mag-computation. Ng oras na. It's 8:39. We will have a break later before tayo makibaka sa ato ang computation. Wala. So, let's move on. Let's talk about the 6 steps in hypothesis testing. So, this is doing research. This is how we do research, and this is how we do testing of our hypothesis. So, number 1, syempre, you have to make your hypothesis. Whether you make a null, that's HO, or an alternative hypothesis. Syempre, after yan ha, identify yung your problem. Mahirap naman gumawa ng hypothesis na wala kang problem. Remember, ang hypothesis is your proposition or explanation to a certain phenomenon or an educated guess, a tentative solution to your problem. So yun muna ang una. Identify your problem first before you can formulate your either null or alternative hypothesis. Now after that, you have to choose the level of significance and the sample size. So remember the level of significance. This is like a room for error for us. And most of the time for survey research, that's 5% or 0.05. So most likely we will be using 0.05 for our level of significance. And you have to compute the sample size, especially if you are doing survey, like your respondents, or example, residents of General Santos City, it will be impractical and it will be most likely impossible for you to reach all the residents of Gensan. That is why we are going to do sampling. So we have to compute first the sample size before we can really move on to the data gathering phase. Okay? If you have the numerical data already, then we have to determine the appropriate test statistics and sampling distribution. Okay? Pag naanatay data. And then determine the critical values. Sa pag-determine ng critical values, we have tables here for the critical values, and I'll also give this sa inyo. The numbers there is masyadong marami, so definitely I will not be requiring you to memorize that. Even statisticians don't memorize the critical values in the table, but you need to secure a copy para pag mag-compute na ta, As in, tama yung sagot nyo, tama din yung magiging decision natin whether to accept or reject the null hypothesis. So in the critical values in the table, actually, ang makikita nyo dyan is yung significance level. So depende kung ano yung ginamit. Sabi ko kanina, most of the time, it's 0.05. And then we will also be identifying the degree of freedom. I'll be discussing that later. And also, we will be identifying whether we are doing a one-tailed test or a two-tailed test. So, paano nga sila malaman? Depende sa hypothesis if it's directional or non-directional. Pag one-tailed test, directional. Pag two-tailed test, non-directional. So, you cannot see comparison terms for this. Okay? And then, ito, collect data and compute the value of the test statistics. So, we are going to compute for, depende kung ano yung kinocompute natin dito. Depende din kasi sa test. Like kung sa t-test, syempre, ang kinocompute natin, the t-score. Okay? And then after that, pag meron na tayong like t-score or r-score for our Pearson R na testing, we have to decide whether to accept or reject our null hypothesis. It's always about the null hypothesis talaga. Okay? Now, the p-value, ito yung makikita natin sa mga statistical software. Like we input data collected from the experiment or from the survey, and then input natin ito sa mga softwares like the SPSS and the JASP. Pag nag-generate na yan sila ng result, ang binibigay talaga nila is the p-value. Okay? The p-value yung binibigay na scores ng ating mga statistical software. Okay? So this one will tell us the probability that the data would be at least this inconsistent if the assumptions is that the hypothesis is true. So, ang p-value actually, hindi natin siya nako-compute manually. Hindi tayo nagko-compute ng p-value manually. Pero yung software na mismo ang mag-a-identify niyan in association with the critical values later in our table. But the goal when we are dealing with the p-value is to always reject the null hypothesis. And ito yon yung mga values. Actually, I'm simplifying this kasi in research, yung ginagawa lang talaga natin is again, automatic na reject or accept the null hypothesis. Marami kasing value itong table na ito. Example, gumamit tayo ng just plus and then nagbigay na siya ng p-value. If the p-value is more than 0.1, no evidence against the null hypothesis. So the data appear to be consistent with the HO. Ano ibig sabihin yan? You have to accept the null hypothesis. Meaning, tama yung null hypothesis if the p-value is greater than 0.10. Now, if the p-value is between 0.5 and 0.10, between yung p-value na binigay ng JASP or ng SPSS, there is weak evidence against the null hypothesis in favor of the alternative hypothesis. Okay, if it's between 0.0 and 0.05, moderate evidence against the null hypothesis. So magfe-favor pa rin tayo ng alternative. And kung 0.01 to 0.01, ito strong evidence na talaga ito na against the null hypothesis. So ang ife-favor also is the alternative, and the p-value is less than 0.01, very strong evidence na yan siya against the HO in favor of the HA. Pero this one is like confusing. Sa real na world ng statistics, ito lang yung tinitingnan. Depende yan siya sa level of significance. So sabi ko kanina, ang mostly ginagamit natin is 0.05, right? 5% room for error. Now, if you have already your gathered data, tapos nag-p-value ka na, nag-test ka na sa JASP or sa SPSS, if the p-value is more than 0.05, again, if the p-value is more than 0.05, you have to accept the null hypothesis. Ito yung ginagamit talaga natin. Okay, you have to accept the null hypothesis, meaning there is no significant difference between the groups that you are testing. But if the level of significance is less than 0.05, this is the time that we reject the null hypothesis. Mare-reject ang null hypothesis if the computed p-value is lesser than the level of significance. So you have, ano yan siya, merong significant difference or merong significant relationship between the variable. So again, nakadepende kasi ito sa level of significance. So kung ang ginamit na level of significance ay 0.01, it's very strict, especially for experimental research. Ganon pa rin, class. If the p-value is more than 0.01, you still have to accept the null hypothesis. If it is lesser than 0.01, then you have to reject the null hypothesis. So that's how we make the decision for research if we are already done with statistics. So please copy this na lang. Medyo complicated kasi itong nasa table. Okay? Questions? Let's simplify our statistics na world para di tambo ang aning daghan kay numbers. Wala? Sure na? Oras na. Still have time. Sige. So, introduction pa lang to siya. Introduction to siya sa mga terms na you need to know before we'll really move on sa mga testings. So, ang alam ko, you are familiar with ANOVA, or kung hindi niyo alam paano yun siya gawin, at least you have heard about it, ANOVA or t-test. So mag-start na ta karon, pero let's start first with the z-test. Okay? This is our first inferential statistics. We are done with the descriptive, right? The measures of central tendency, the measures of variation like the standard deviation. This time, inferential statistics na talaga tayo. The first one again is, okay, sige na, the z-test. Hindi natin mag-t-test, mag-z-test sa ta. Now, what are you going to remember? What should you remember about z-test is it is a parametric test. When you say parametric test, dalawa kasi yung sa statistics ha, umbrella nito. Statistics. Let's not think about inferential and descriptive first. Dito, ano ko na lang talaga. So, descriptive, then we have inferential. Sa inferential statistics kasi, class, meron din tayong two types, parametric and non-parametric test. I will discuss this next meeting, yung talagang deep discussion of the two. But you need to take note lang na when you say parametric test, there is normal distribution of the data. What does it mean? Remember our lesson last week about normal distribution? If you plot your data, you will get a bell-shaped graph. Okay? Meaning your data is normally distributed. You will have a mirror image. If you divide your data, you will have you will have the mean, median, and mode at the center. So pag normal distribution, there is normal distribution of the data. This is what we call the parametric tests. And number one testing under sa parametric test is the z-test. Therefore, kung sa sinugdan pa lang you have identified that your data is not normally distributed, like when you draw or when you compute for the skewness, like ganito yung kanyang yung kanyang itsura, skewed siya, either positively skewed or negatively skewed, you cannot use the z-test class. I hope that is clear. So everything starts first with the identification whether your data is normally distributed or not. Pag okay na, then let's use the z-test. Again, kasi para metric test siya. Okay? Sige. Now, aside from that, z-test ha, parametric. Number 2, when are we going to use the z-test? Kailan natin gagamitin si z-test? Alam na natin na normally distributed yung data mo. Pero kailan mo gagamitin si z-test? This is used to compare two means, the sample mean and the perceived population mean. Okay? So, example, meron ako example dito. Wait lang ha, let me check. Ito yung example dyan sa z-test. Example ito. This one is the name of the company. The BRKPD company asserts that the average lifespan of their brake pads is at least 43,000 kilometers. Ito yung population mean na tinatawag. Their assumption yung sa product nila maglalast siya if gagamitin up to 43,000 kilometers. So to check whether the claim of the company is true or not, there is a jeepney operator that puts these brake pads to their 50 jeepneys, which get the average lifespan of brake pads at 41,800 kilometers. So this is doing an experiment whether tama yung claim na 43,000 kilometers yung lifespan ng product. So nag-test siya sa 50 na jeepneys and ito yung nakuha niya na mean. 41,800 na. Mean na ito ha, kasi mahirap naman kung isa-isahin natin lahat ng results for the 50 jeepneys. So mean na yan, average na. So merong standard deviation na given, so pwede mong gamitin si z-test dito. Again, kailan gagamitin si z-test? If we are comparing two, only two ha, dalawang means lang. The population mean and the sample mean. So nakikita natin dito sa problem, this one is the population mean, kabuuan sa lahat ng tinetest natin or yung target population natin. And since this one is just a sample, so ito yung sample mean natin. Yan ang gamit class ni z-test. I hope klaro yun. Also, pwede din naman gamitin si z-test if we are comparing two sample means taken from the same population. So, hindi lang siya about population versus sample. Pwede din siyang sample versus sample as long as both samples are taken from one population only. So like you are testing whether there is a significant difference between the mathematics ability of the first year pharmacy students and the second year pharmacy students. So both are taken from the same population, pharmacy students, example of GSD MSFI, but we will have two means here. One is for the mathematics ability of the first year, and then the second one is the mathematics ability of the second year. So dalawang means yun, and if we are going to compare, pwede natin gamitin si z-test as long as the samples are equal or greater than 30. Pag hindi lumampas sa 30 ang iyong sample for both groups ha, na kinukunan natin ng difference, hindi mo pwedeng gamitin si z-test. Okay? So, ito yung gamit ng z-test class. Anong una? You have to make sure that the data is normally distributed. And you also have to make sure that the sample size is greater or equal to 30. Okay, so when are you going to use the z-test? If you are comparing two means. Like we are getting the difference. Pero itong two means, it can be population mean versus the sample mean, or pwedeng both samples, sample versus sample, sample. Pero kailangan taken ito from the same population. Again, yan yung gamit ng ating z-test. Naintindihan ba yon or may gustong i-clarify? Wala. Okay na tahan. Nagkasinabutaan na atong z-test. Sige. So, let's have now the computations. I'll be giving you the formula. This is z-test 1 sample mean. So ito yung gagamitin natin na formula if we are comparing. Ano yung i-compare natin? Mean ng sample and ang perceived population. So, isang sample, tapos sa population na. So, ito yon. Ito yung ating formula. So, ginagamit again for comparing perceived population mean. And if the population standard deviation is not known, pwedeng gamitin natin yung standard deviation mismo ng sample as a substitute. So, ito, z. That's the z-score. Most of the time, kung ano yung tinetest natin, yan yung tawag sa kukunin din natin. T-test, t-score. Tapos z-test, z-score. So z-score is equal to mean minus the mu times the square root of n divided by rho. Okay? So itong z, the z-score ito. And then the mean here is the mean for the sample, for the sample. And then itong mu here is the perceived population mean. Perceived lang. Hindi naman talaga siya totally na kailangan yun talaga yung exact value. As long as we have like a knowledge about the population mean, we can do that for the z-test. And then n is the sample size. So remember, mean here is for the sample. So n is kung ilan sila lahat, ilan yung subjects natin when we conducted the study. And then sa baba, rho is our standard deviation. So supposedly this should be the standard deviation of the population, but if there is an instance na hindi known ang standard deviation ng population, mahirap kasi talaga mag-conduct ng study sa whole population. So we can use the standard deviation of the sample as a substitute. Okay? Please take note of the formula. Okay. Now, these are the steps in solving the z-test for one sample mean. Una, determine the mean of the sample. Kung kailangan mo muna magkuha ng mean class kasi pag nagkanda ka ng survey or nagkanda ka ng experiment, individual results yun. So kung meron kang 30 na sample, 30 scores yun, you have to get first the standard deviation and also the population. I mean, the mean and the standard deviation. Okay? And then get the difference of the sample mean and the population mean and multiply it by the square root. This is just for the solution. So, syempre, pag meron ka na dyang mga values, i-substitute mo na and do the math. Mean minus the population mean, tapos i-multiply mo siya sa square root ng sample size. And then determine the quotient of the step by the population standard deviation if it is known. So step by step talaga yan na pag-solve ha. After mo i-solve dito sa taas, i-divide mo siya sa standard deviation na nasa baba. Tapos, number 4, ang pinaka-importante, compare the result of the table or the tabular value using the set level of significance. So, Ito yung level of significance. Ito yung table na gagamitin natin. This is for z-test only ha. Again, this is for z-test. Now, dalawang level of significance lang ito. Actually, marami yan sila. Di ba? Meron pang 0.001. Pero sa research kasi, ito yung mostly ginagamit natin, 0.01 and 0.05. So, iset natin yung level of significance. At kailan ginagamit si 0.01? Kapag experimental studies na very strict. Pero most of the time, for like animal testings and also with survey research, we use the 0.05. Now, after that, you have to identify whether you are going to do a one-tailed test or a two-tailed z-test. Paano nga malalaman ulit kung one-tailed or two-tailed ang gagamitin? Di daw if nakikinig sila. Ano kaya? Paano natin malalaman if we are going to do one-tailed test or two-tailed test? Okay, very good. If merong direction or wala, yung ating hypothesis. So, balikan muna yung hypothesis before ka mag-decide class. Lahat ng testing natin, t-test and even ANOVA, meron silang one-tail and two-tail. Kasi nakadepende talaga yon kung anong klaseng hypothesis meron ka. Kung two-tailed ba siya or one-tailed. So kapag ka one-tailed class, tapos example yung ating level of significance is 0.05. So ito yung tinatawag na alpha or the critical value. Okay? So ito yung critical value natin if 0.05 ang level of significance and we are doing one-tailed test. Kasi may direction yung ating hypothesis. Okay, merong comparison. Meron kang comparison terms na greater than, lesser than, and so on. So positive and negative 1.645. Now, kapag tinignan mo yung hypothesis mo and walang comparison terms, that will be two-tailed. Tapos kung again, 0.05 yung sinet natin na level of significance, the critical value is positive or negative 1.96. Again, positive or negative. Positive or negative na siya ha. 1.96. Ang tawag natin sa mga numbers na yan, critical values. Okay? Critical values. Sige, you have a copy of this table naman. Not asking you to memorize those numbers. You can make a index card for this. Kasi, or you can just print this. Kaya napatay t-test nga dako kayo yung table. Okay, so take note. Take note of this. Kasi this is very important during the interpretation part and during the making of decision whether to accept or to reject the null hypothesis. Take note, if the z computed value, yung na-compute na value sa z-test is greater than the z tabular value. Ito yung z tabular value ha. Now, pag mas malaki daw ang na-compute natin na z-score kesa sa number na nasa table, reject the null hypothesis. Take note of that para tama yung decision natin. Kasi ito yung isa sa may pinakamalaking score during my quizzes and my exam. Malaki ang points sa solving, pero malaki din ang points sa interpretation. Yan kasi ang pinaka-importante din. Isa sa pinaka-importante, alam nyo paano mag-interpret ng results of the testing sa statistics. So again, pag mas mataas daw ang makuha mo na z-score kesa sa nandun sa table, like this one, if we are doing a two-tailed test, if mas malaki yung na-compute mo sa 1.96, whether it is positive or negative, you have to reject the null hypothesis. But if it's the other way around, mas malaki yung tabular z-score kesa sa na-compute natin na z value, then we have to accept the null hypothesis. Okay? Please take note of that. Now, let's try to solve this. Ay, anong oras na? Before ta mag-solve, mag-break sa siguro ta, no? Okay, para mag-sink in sa inyong habe, you try to absorb, though wala akong nag-expect na ma-absorb tanan, itong ating interpretation na part. Tapos later, after we go back from the break, ito na yun, i-compute natin yung sample problem, and then after sa computation, we really have to make a decision. Okay? Sige. 20 minutes break, diba? Pag 3 hours. So be back at 9:27. Continue. So we have here an example. The BRKPD company asserts that the average lifespan of their brake pads is at least 43,000 kilometers. To ascertain the accuracy of this assertion, a jeepney operator puts these brake pads to their 50 jeepneys, which got the average lifespan of brake pads at 41,800 kilometers. With the standard deviation of 2,580 kilometers, use the z-test at 0.05 level of significance to determine if the claim is true. Before tayo go into the computation, let's make first the hypothesis. Remember the step 1 in solving the z-test? Determine the mean of the sample, the standard deviation if the population is unknown. Wait, not this one, not this one. This one, steps in hypothesis testing. State the alternative and the null hypothesis. So gawa muna tayo ng hypothesis before tayo mag-compute. So una, let's have first the alternative hypothesis. So what do you think will be the most applicable alternative hypothesis here? We are comparing two means. Ay, ayaw niya na. So since we are comparing the brake pads, siguro our HA will be like this. There is a significant difference. Difference ha kasi z-test ito. Difference talaga ang hinahanap. There is a significant difference between the lifespan of the brake pads according to the company lang ilagay ko ha. And the result of the investigation of the jeepney operator. Okay? So yan yung ating alternative hypothesis. Merong significant difference yung lifespan of the brake pads according to the company and yung result of the investigation of the jeepney operator. Pag ginawa natin yung ating HO or our null hypothesis, lagyan mo lang siyang no. Okay, so parehas lang sila lahat. There is no ganon, significant difference between the lifespan of the brake pads. Hindi ko kasi siya makopy pag kapihin ko itong mawala ito lahat. According, i-shortcut ko na lang to the company and the result of the investigation of the jeepney operator. Ito yung ating pwedeng maging hypothesis. The first one is alternative, and then the second one is the null. So the only difference is that the null hypothesis is stated in the negative form. Now, if we already have the hypothesis, we can do the math. Ano nga yung formula natin? The z-score is equal to the mean minus the mu times the square root of the n divided by the row. So let's identify the given in the problem. The mean is for the sample. So anong ginawa? Ang jeepney operator used the brake pads sa 50 jeepneys niya and ito yung naging mean. So hindi na inisa-isa yung results ha. So you have here 41,800 kilometer minus, let's not just write the kilometer para hindi masyadong haba. Okay lang wala itong unit. And then the mu, remember, is our population mean. And that will be according to the company. Yan yung population mean that is coming from them. Na yun daw yung lifespan ng kanilang brake pad. So this is 43,000. Okay? And then multiplied sa square root ng small letter n. Ano nga yung ibig sabihin ng small letter n? Sige, that's the sample size. And what is our sample size here? It is 50. Kasi dyan yan, tinest yung mga brake pads. So this is square root of 50 divided by the standard deviation. In this kind of problem, we don't need to compute isa-isa the mean and the standard deviation because all are already given in the problem. And this is the standard deviation, 2,580. So let's do the math. 41,800 minus 43,000 is negative 1,200 times what is the square root of 50? This is 7.07106782 divided by 2,580. And then this is negative 1,200 times 7.07106782 is negative 8485.281384 divided by 2,580. What's the answer? The z-score here, 2 decimal places lang tayo, negative 3.29. So ito yung ating z-score. Yan, meron na tayong z-score. The next thing to do is to interpret that result. Ano bang ibig sabihin ng negative 3.29? Na paano natin yan gagawin? We have to look at the table. So let's go back to our table, this one. And then identify the critical value. First, let us see, use the z-test and the level of significance should be 0.05. So dito tayo sa 0.05 plus dito tayo. Pero the question now is whether are we going to use a one-tailed test or a two-tailed test? What do you think? Sa tingin ninyo yung gagamitin natin, one-tailed or two-tailed? Okay, paano nga malaman kung one-tailed or two-tailed? Two-tailed, di ba? It's by looking at the hypothesis. So look at the hypothesis if there is comparison words or are we favoring one group to another? May sinabi ba dyan na fini-favor mas totoo yung sinasabi ng company or yung results ng experiment? Wala no? So diretso lang, 'di ba? Walang binibigyan ng favor. Wala tayong direction. So this one is a non-directional test which means we are going to look at the two-tailed test and that our critical value is positive or negative 1.96. So actually, yung positive or negative dyan, pwede siyang positive, pwede siyang negative, but ito talaga yung titingnan. Yung number dyan, 1.96. Now, paano natin i-interpret? Yung result natin is negative 3.29. Again, you have to disregard the plus and minus sign ha. Yung number lang yung titingnan. Now, anong sabi? If the z computed value is greater than the z tabular value, reject the null hypothesis. Isulat ko siya. Ang computed na z, lagay ko na lang z and then c, meaning computed, is negative 3.29. I told you to just disregard the negative sign. And then the tabular z, what was that again? Plus or minus 1.96. So in by this one class, you just have to look at the numbers, disregard the sign kasi the result of the secant, ang ibig sabihin yan can either be positive or negative. So kung nakita natin dito, 3.29 is actually larger than the 1.96. And this is the computed, this is the tabular z. So ano nangyari dito? If the z computed value is greater than, yes, this is greater than, then we have to reject the null hypothesis. So, i-reject daw natin ngayon ito. Hindi daw ito totoo. Therefore, tama ano yung tama? Tama yung ating alternative hypothesis. There is a significant difference between the lifespan of the brake pads na result or yung sabi as yung claim ng company and ng result ng experiment ng jeepney operator. Okay, meron daw significant difference. So most likely hindi talaga 43,000 kilometers yung lifespan ng brake pads. Kasi again, merong significant difference yung result ng experiment. Yes, tama. We have to reject the null hypothesis and we have to accept the alternative hypothesis. Okay? So ito yung klase ng experiment na parang 'di ba, meron silang claim. So we will test whether their claim is correct or not. But then after the experiment, nakita natin na hindi pala magkapareho yung result ng experiment and yung claim ng company. Kasi according to these values, yes, there is a significant difference sa lifespan ng actual na mean or experimental mean and yung perceived mean coming from the population or coming from the assertion only of the company. So yung 41,800 kilometer for the 50 samples is different, significantly different from the 43,000. Nakuha yon? Do you have questions or like clarifications? So, hindi naman talaga siya mahirap i-compute class as long as alam nyo yung formula and you can properly understand the problem. Doon na tayo mag-check talaga after computing if you have understood how to interpret the result of the z-test. What time is it now? Yeah, i-disregard ang negative and positive sign. Ang nakalagay kasi sa table, ganito, positive or negative, which means the result of the z-test can either be positive or negative. But what we are looking there is the number lang. If mas malaki siya sa number na 1.96 or like 1.645, i-reject natin. Okay? Re-reject natin si null hypothesis. We will have sample problems for that later. Mag-practice kayo. Now, ito yung z-test for two sample mean. Remember, si z-test cannot be used only doon sa comparison between the population mean and the sample mean. Pwede din siyang gamitin for two samples as long as these two group samples are drawn from the same population or normal population. And kailangan lang natin i-make sure that the number of samples for each group is umabot ng 30 or pataas. So, pinicturean ko lang talaga yung book na kasi nahirapan akong mag-type ng formula. Plus, you can have an index card for the formula. You may write the formula in an index card, and you can also write the table there. Yung table natin for the critical scores natin or critical values. Now, this is our formula for the z-test for computing two sample means. So you still have here the z-score and then x1 minus x2 divided by the square root of the s1 squared divided by n1 plus s2 squared divided by n2. So medyo mahaba pag two sample mean. Yung x1 dyan is the mean of sample 1. Yung x2 naman, the mean of the sample 2. Now, sa baba, S1 squared is the variance of the sample. Actually, ganito yan. Pag hindi given si variance, pag variance na kasi diretso lagay mo na siya dyan. Pero pag ang gamit ay, ang binigay ay standard deviation, yung S dyan is actually standard deviation. Tapos pag i-square mo yung standard deviation, that will be the variance. Kaya ang nilagay sa formula, hindi talaga variance. Instead, standard deviation kasi most of the time, ito yung given sa problem. So you just need to square the standard deviation to get the variance. And then S2 squared for the variance of the sample 2 and then yung N sa baba, that's the sample size. Sample size ng group 1 and sample size ng group 2. Okay? Now, we will be using the same table for the interpretation. So look at the table. It's actually the same with that of the one sample mean when we compare the sample and the population. Okay? Sige. And then, so take note, parehas din ang pag-interpret. If the z computed value ng ating computation no, is greater than the z tabular value, you have to reject the null hypothesis. So the same table, the same way of interpretation. Ang nabago lang dito is yung ating formula because instead of comparing the mean of the sample to the population mean, we will have two groups of sample here. So let's try. May time pa ako, diba? Yeah, may time pa ako. We have here a guidance and testing department administered to incoming freshmen in the College of Arts and Sciences entrance examination. The psychometrician randomly selected 120 students of CAS from BS Psychology and AB Broadcasting. The mean scores, these are the results of the entrance exam. The mean scores of the given sample where mean of sample 1 is 85 and the mean of sample 2 is 80. So hindi na again binigay isa-isa yung results ng experiment. Mean na, not experiment, investigation lang. Mean na agad yung binigay. And then the variances were 35 and 30. Take note that variances yung given hindi standard deviation for sample 1 and sample 2 respectively. So, is there a significant difference between the two groups. And then additional instruction, we have to use 0.05 as the level of our significance. Okay? Paliit ko lang muna siya ha, para I'll have a lot of space for the computation. Sige. Pabasa pa yun siya. Okay, what was our formula again? Oh, no. Let's have the hypothesis first. Actually, the hypothesis is also almost given in the problem. If you look at the problem here, wait, this one, in question form lang siya, is there a significant difference between the two groups? Pero let's just complete the sentence. We have here the HA. There is, remember, nakastate siya in its positive form. So there is a significant difference between the entrance, complete ko lang siya, entrance examination scores of, ano yun, BS Psych and AB broadcasting students. So remember, di ba, characteristic of our hypothesis is it should be clear and it should be specific. So that is the reason why kinomplete ko siya. There is a significant difference between the entrance examination scores of the BS Psych and the AB broadcasting students. Pag pinagawa kayo ng null hypothesis, then we will just place no here. So there is no significant difference between the entrance examination scores of BS Psych and AB broadcasting students. Okay? So ayan na yung ating hypothesis. Ito na yung ating hypothesis class. Now we can proceed in the computation of the z-score. So ano nga yung formula natin? Z is equal to mean 1 minus mean 2 divided by, sorry, I forgot the 1, the square root of the variance. So itong S1 squared is the variance 1 divided by the sample size plus the variance 2 squared divided by the sample size also. Now, ano yung group 1 natin? Group 1 natin can be the BS Psych. And ano yung mean niya? The mean for the group 1 here is sample 1, it's 85. Yung kanyang variance is, kasi malibat ko, it's 35. Yung sample size niyan, nakikita ninyo, the psychometrician randomly selected 100 students of CAS from BS Psychology and AB Broadcasting. Let me just check first if tama itong kinap ko na problem. Wait lang. Okay, let's continue. Tama pala. Okay, now, yung end dyan is 120. Gusto ko sana ng ibang color ba? Okay, and then for the group 2 class, this is for the AB broadcasting. The mean here for their score is 80. Yung variance naman is 30 and the sample size is still 120. By the way, it's 120 students per group yan siya. 120 for psych, 120 for the AB broadcasting. So since we have identified the given, we will just substitute the given here. The mean for the group 1 is 85 minus the mean for the group 2 is 80 divided by the square root. Sabi ko kanina, yung S, standard deviation yan. And mag-square ka lang pag standard deviation ang gamit. Kasi yung variance class, ang formula nito is standard deviation squared. Kaya meron siyang S1 squared. However, in the problem, hindi kasi standard deviation ang binigay. Diretso na siya variance. So kapag ka ganon, hindi na tayo mag-square ha, diretsong variance na yan siya. So this is just 35 divided by 120 plus, diba? Makalimutan ko. And then the group 2 is 30 and still the sample size is 120. So, where is my calculator? 85 minus 80 is 5 divided by square root of 35 divided by 120 is medyo mahaba. 0.291 and then continuous ito. Huwag kayo mag-round off during the process ha. Mag-round off tayo sa final answer na. So be patient with the numbers na masyadong marami. And then 30 divided by 120 is 0.25. So this is 5 divided by the square root of 0.25 plus 0.291667 is 0.541. And then still have the 6 here. Ayan. And then let's continue here on this side. You have there 5 divided by, let's get the square root of the 0.541. It's 0.735980667. So let's divide 5 divided by the 0.73598000722. The answer is what? What is our z-score? 6.79. Very good. This is 6.79. So this is class our computed z-score. Okay, computed z-score ito. Now, let's go back to our table. Sorry ha, hindi ko na siya ma-delete. So, please bear with all the writings sa screen. Sige, number 1. The instruction is to use the 0.05. So, we will be using this one. Now, question, will this be a one-tailed test or a two-tailed test? Sa tingin ninyo? Yeah, two-tailed. Bakit two-tailed? We are not favoring one group, right? Hindi tayo nagsabi na mas mataas ang score ng mga BSI kaysa sa mga AB broadcasting students or the other way around. Ang sabi lang natin sa hypothesis, there is a significant difference. So, titingnan natin ulit ha. Pag two-tailed test, it's, wait lang. A one-tailed test, is a directional test. We use this if we have the greater or lesser than, meron tayong direction. Pag two-tailed test, non-directional. So automatic kasi yun siya na there is no significant difference between the two means. So tama yan siya, class, na gagamitin natin si two-tailed test. Two-tailed test, which means that our tabular z-score is plus or minus 1.96. So, asan na yun? Balikan natin yung ating problem. Ito yung problem natin, right? So, yung ating tabular z-score, I know the computed z-score is 6.79 and our tabular is 1.96. Paano natin siya i-interpret? Sabi sa rule, if ang computed z daw is greater than the tabular z, you have to reject the null hypothesis. And as you can see, yes, mas malaki nga ang computed z-score kesa kay tabulated z-score. Therefore, we have to reject this null hypothesis. And what we are going to accept is the alternative hypothesis. So, according sa mga scores na nakuha ng psychometrician, there is a significant difference between the entrance examination scores of the BS Psych and the AB broadcasting students. So, yan yung gamit class ng ating z-test for two sample means. Makikita natin sa mga scores collected if meron bang difference yung one group and another group. So ito lang yung binigay. Mean lang ito ha, kasi hindi na inisa-isa ang lahat ng scores ng 120 students. So yung mean scores ng mga BS Psych is different from the mean score ng entrance exam ng mga AB broadcasting. So I hope nakuha yon. Do you have questions? Reject the null hypothesis, yes, and you have to accept the alternative hypothesis. Okay, I hope you learned something this morning. I will give you actually an assignment for this para mag-practice kayo. Sundan nyo ha yung ano. Kindly remind me, for example, hindi ko ba nabigay yung video, especially nowadays, I'm so busy. Ako'y gana mag-unsa-unsa sa akong kabisi. So, makalimot ko with my videos like that. So, wala ta quiz karon. So, next week na lang yung quiz natin for the normal distribution. Anyway, that was just a very short discussion. So medyo mahaba lang ito sa manual computation ng ating Z testing. You can do that class like if you want to determine also if there is a significant difference between the entrance exam result of the BS Pharmacy students and the BS Medtech students. Yung gagawin lang ng psych, yung ano natin, guidance office is to get the scores, get the mean for the two groups, and we can compute using the z-test. And later on, we can conclude if there is really a significant difference between the scores of the medtech and the pharma. So again, when do we use our z-test? Una, we have to make sure that the collected data is normally distributed since this is a parametric test. Number two, we have one sample z-test and ginagamit natin siya if there is an identified sample mean and at the same time population mean. Yun yung una nating kinumpute kanina. Pero kapag walang population mean but we have two samples taken from the same population, we can also use the two sample z-test. As long as we have to make sure that the sample size is 30 and above. Okay? And then another thing, you have to be sure with your level of significance. So most of the time, we are using the 0.05 kasi masyadong strict yung 0.01. It means you only allow 1% room for error. So 5% tayo mostly. And, ang tawag dyan, you have to identify properly also the type of hypothesis, whether it is directional or non-directional, para alam nyo whether two-tailed test or one-tailed test yung gagamitin. So tingnan nyo lang yung table. Yung rule sa lahat actually is computed na z, if mas malaki siya compared to the tabular z, you have to reject the null hypothesis. Okay? Questions or clarifications? Okay, magkasinabutaan na. Sige. So there are instances, class, that you will be asked to look for the degrees of freedom. Actually, ito gagamitin natin ito sa t-test, yung degrees of freedom. Hindi kasi siya nagamit sa z-test. Pero pag sinabing degrees of freedom, gagamitin natin pa rin siya sa hypothesis testing, and it is referring to the number of independent pieces of information that went into calculating the estimate. Meaning, ito yung mga data natin that are free to vary. Actually, this is just dependent on the number of samples that we have. Ang formula natin for the degrees of freedom is n-1. N being the sample size. So if you have 30 sample size minus 1, you have 29 for the degrees of freedom, which means these 29 here are free to vary. So bahala na kung ano yung results nila, ano yung values nila. Kaya nga siya tinawag na degrees of freedom. But again, if you are asked to compute for that, do not forget the formula. Degrees of freedom is just equal to n-1, n being the sample size. This is used for one group of sample only. Kasi kagaya ng ginawa natin kanina sa z-test, yung bago lang, meron tayong two groups of samples. So kapag kaganon, now we have two groups of samples, class, we will be using this formula. BF is equal to N1 plus N2 minus 2. Meaning we have to add the sample size of both groups tapos magma-minus 2 tayo. So kagaya kanina, kung magko-compute tayo ng degrees of freedom, di ba 120 yon for psych, 120 din for the AB broadcasting, tapos minus 2. Sorry, hindi ko nalagyan pala ng open parenthesis here. So this will be equal to 240 minus 2. This will be the degrees of freedom is equal to 238. So meaning yan, for that certain result, there are 238 values or data that are free to vary. Again, when do we use this? If we have two groups for our samples, or two samples to be exact. Okay? Now, the critical values, class, ito yung nasa table. Kaya kagaya kanina, yung kinuha natin is plus and minus 1.96. Again, ang tawag doon sa numbers na yon na nasa table are critical value. So, ginagamit natin sila to determine whether we are going to reject or accept the null hypothesis. Possible po ba na magkaiba ang sample size ng dalawang grupo? Yes, it is always possible na magkaiba ang sample size ng dalawang grupo. Like, nag-test ka sa isang grupo, 30 sila lahat, tapos pag yung sa isang grupo, 32 sila. Pwede din yon, hindi pantay yung sample size. Yung sa example lang natin kanina is pantay lang talaga siya. Okay? So again, possible. So again, yung mga numbers natin sa table, ang tawag natin sa kanila ay critical values, and these are the numbers where we are going to compare with the computed scores to arrive in a decision whether we are going to accept or reject our null hypothesis. So always kasi yan siya, class, na if the computed score is greater than the critical value or the score na nasa table, you really have to reject the null hypothesis. Okay? And this corresponds to the alpha. Kaya 'di ba, before mo tingnan kung ano talaga na critical values ang gagamitin, kailangan mo muna i-identify what will be the significance level, whether it is 0.05 or 0.01. So, para ma-fix natin yung talagang critical values na gagamitin for the decision making. Okay? So, yun yung mga kailangan yung malaman so far. Again, I'll post plus an assignment due next week. Hindi naman ako nagbibigay ng assignment na due today or due 3 days after. It's always before the class. Please wait for it sa Schoology. The deadline, syempre, is Thursday, kay Friday man ta mag-check ato. So sa Friday next week, we will have our quiz, normal distribution. Normal distribution is very short kasi, so iisa ko na lang siya with our discussion this morning. But before we'll have a quiz next week Friday, we will discuss first your assignment. So be sure to submit it before Friday.